All of the shapes that we've come across so far have been two-dimensional shapes, flat shapes. A dimension, remember, is a direction that we can measure in. So two-dimensional shapes have two directions that we can measure. We can measure their across distance from left to right, and we can measure their up-down distance from top to bottom. Most things in the world, however, are not flat. Most things in the world are what are said to be three-dimensional. There are three directions that we can measure in. This object, for example, I could measure it across and I can measure it up and down, much the same as the 2D shape, but I can also measure how far back it goes, how far away from the viewpoint it moves. It therefore has three dimensions, and there are a few things we need to know about certain three-dimensional shapes. We need to know the names of some key three-dimensional shapes. We need to know a couple of terms to do with them, and then we're going to move on to work out a few properties of them in future lessons. But let's have a look at some standard shapes first of all. The first standard three-dimensional shape is this one, and this is a cube. Now a cube is kind of like the 3D version of a square. So we've got square bits on the sides. 6 squares go together to make up a cube. So all of these lines, these edges here, are the same length, like in a square. Classic cubes from life, well, there is this one here, this nice blue one. In terms of common cube-shaped things in life, think things like dice. The next 3D shape we need to be aware of is the cuboid. If a cube is like a 3D version of a square, then a cuboid is kind of the 3D version of a rectangle. So we've got different rectangles that go together to make up this cuboid. They stick together. So this is like your classic box kind of shape. Circle at the top, circle at the bottom, and a rectangle that has been wrapped around to make this outside edge. This is a cylinder. From life, think about things like tins of beans, tins of soup, that kind of thing. Circle at the top, circle at the bottom, rectangle that's been wrapped around the outside. A cylinder. Your classic Toblerone box shape now, or tent if you prefer. Triangle at one end, triangle at the other, and then 1, 2, 3 rectangles that join those together. This is a triangular prism. We're going to come back to this word prism very shortly. But a triangular prism, Toblerone box shape. Circular base with tapering sides up to a particular point at the top. Party hat kind of shape, a cone. Same shape as an ice cream cone if I turn it upside down. A cone. Something you might see if you were to go to somewhere like Egypt, a pyramid. But there are two kinds of pyramid. This is the first kind. This one has a square on the base and then 4 triangular sides that slope up to a point at the top. This particular type of pyramid is said to be a square-based pyramid because it has a square base. And while the square-based pyramid is the classic pyramid that you might think of, there is also this kind of pyramid. So this has a triangle at the base and then 3 more triangles that slope up to a particular point right at the top. And this is a triangular-based pyramid.
Lovely as these colourful 3D plastic shapes are, they are lacking in one particular area, and that is that they do not have one of these in the set. Your classic ball shape, also known as a sphere, where sphere is just the fancy word for a ball. So examples of spheres from life, something like a football, say, or a tennis ball, or any other kind of ball that you might want to think of.
Couple of terms that we need to be aware of. So this is a quick sketch of a cube, although these words apply to any of the shapes. First term we need to be aware of, the flat sides. That's the shapes, the 2D shapes that make up the 3D one. They are said to be faces. So the faces of a shape are the 2D shapes that make up the flat sides. So on a cube, for example, 6 squares are the faces. Then we have these lines, and these lines are said to be edges. So they are the straight lines when we draw, or the bits that we can run our fingers along, the straight edges that we can count. And the final term we need to be aware of are these. They are corners, but they are not called corners in shapes because of course they're not. They are vertices. One vertex, more than one vertices. So one vertex, 2 vertices. Just a fancy word for corners though. The most basic type of 3D shapes question would be to be given a picture of a 3D shape and asked to name it, so you write down the name. The second most basic type of 3D shapes question would be to answer questions on the faces, edges and vertices of a particular one. So if we just have a look at a cube and quickly run through the numbers. A cube has 1, 2, 3, 4, 5, 6 round the back faces that are all squares of the same size. A cube has 1, 2, 3, 4 round the top, 5, 6, 7, 8 around the bottom, 9, 10, 11, 12 edges. 4 around the top square, 4 around the bottom square, and 4 vertical ones. That's 12 straight edges, all the same length. And a cube has 1, 2, 3, 4 around the top, 5, 6, 7, 8 vertices. 8 corners, 8 vertices. A triangular prism, for example, has 1, 2, 3, 4, 5 faces, 2 triangles, and 3 rectangles. 5 faces overall, however. Edges, well, there's 1, 2, 3 on this triangle, 4, 5, 6 on the triangle at the back, and then 3 that connect them. So that's 9 straight edges. And vertices, 1, 2, 3, 4, 5, 6 vertices. 6 corners, 6 vertices. If you are asked to count the faces, the edges, or the vertices of a particular shape, make sure that you count all of them. That's all the ones that exist, not just the ones that you can see in the diagram. A diagram of a cube, for example, will only have 1, 2, 3 faces visible, but it doesn't have 3 faces in total. There's also 1 on the bottom, 1 around the back, and 1 around the left-hand side, hidden to us on the diagram, but they do exist. So you have to kind of picture the shape in your head as best you can and count everything, even the bits that we can't see on the diagram.
There's one final piece of terminology we need to look at with 3D shapes, and that's this word prism. So we've just seen this with the triangular prism. Now the fact that that is called a triangular prism and not just a prism does seem to imply that there might be other kinds of prism. So then the question is, what is a prism? Well, first thing I'm going to do is I'm going to look at all the shapes that we've seen so far, the 8 named shapes, and I'm going to sort them into 2 groups, because some of them are prisms, it turns out, and some of them are not. That the cube, the cuboid, the cylinder, and the triangular prism, funnily enough, are prisms, whereas the sphere, the cone, the square-based pyramid, and the triangular-based pyramid are not prisms. So if the cube, the cuboid, the cylinder, and the triangular prism are prisms, there must be some property that they all share, and that property defines what being a prism is. Now I'm going to give you a clue to see if you can spot what this is, and that's to look along the whole shape and see what they are made up of. And then look along the whole of the not prism shapes and see what they are made up of. It's easy once you know what you're looking for. Well, the cube, the cuboid, the cylinder, and the triangular prism, they have a particular face, a square face for the cube or a rectangular face for the cuboid. The circle at the top of the cylinder, or the triangle at the end of the triangular prism. And if we stretch that shape down along its whole length, if we look along the whole length of that shape, it's the same shape all the way through, as in exactly the same shape. Whereas the sphere, the cone, the square-based pyramid, the triangular-based pyramid, they change. They get wider as we move down the shape, or narrower as we move towards one particular end of the shape. The prisms are the same shape all the way through. So we define a prism as being a 3D shape that is the same all the way along. Another way of explaining that, if we take any slice of the shape, if we cut a slice out of the shape, if the shape is a prism, any slice anywhere along the length will be exactly the same size, exactly the same shape as any other slice. If we look at the prisms again, if we were to take a slice of the cylinder anywhere along its length, we would get exactly the same circular slice. Slice of the cube, exactly the same square anywhere along. The cuboid, anywhere along. The triangular prism, the same triangle anywhere in its length. The sphere, the cone, the square-based pyramid, and the triangular-based pyramid, well, we get the same shape, but it wouldn't be the same size. You think about the sphere, say, wherever you slice it, you're going to get a circle, but we'll get bigger circles in the middle than we will up at the top. The square-based pyramid, we're going to get a square if we slice it along its edge, sort of a horizontal slice, but we're going to get a different square at the bottom than at the top. We're going to get a much bigger square at the bottom. So they are not prisms, because while the slices would give us the same shape, they're not going to give us the same size shape. And the point is that they have to be exactly the same sized slices. So a prism is a 3D shape that's the same all the way along, and any slice of the shape would be exactly the same as any other slice.
On that note, with prisms, they're important enough that they have names of their own, but if we were to look at a cube, for example, we could alternatively call it a square prism, because it's the same square shape all the way through. A cuboid could be thought of as a rectangular prism, because we will have the same rectangular slice anywhere along its length. A cylinder could be a circular prism. We've got a circle at the end, and that circle runs through the whole shape, a circular prism. And we can have prisms of any shape. Here, for example, is a hexagon at the end. 1, 2, 3, 4, 5, 6 sides. So therefore a hexagon, and that hexagon shape runs through the whole of this 3D shape. And therefore this would be a hexagonal prism. Hexagon at the end, stretched down the length, hexagonal prism.
Now we need to know far more about the prisms than we do about the other shapes. So if we just consider these shapes as a whole, the cube, the cuboid, the cylinder, and the triangular prism, they are the prisms that we need to be aware of. We have to know much more about those than we do the sphere, the cone, and the two pyramids. Those four particular shapes, really we just need to know their names. Particularly, we need to be able to recognize what they are and write down the name. The other four, we're going to take forward into other things that we need to do with 3D shapes.